This is part 1 of section 2.5, implicit derivatives. And before I go into solving some of these problems, I'm going to show you the types of equations we'll be dealing with. This one's going to be not necessarily a function anymore. They're going to be curves which have x and y in them. So that's going to be what example 1 looks like. Example 2 is going to have the same thing, x and y in it. And then example 3 will have x and y in it. So they're not necessarily going to be functions, they're going to be curves. And in class I'll show you what these curves look like. So here's our 3 basic steps to finding implicit differentiation. First step is going to be to find the derivative with respect to x to both sides of the equation, or the equal sign. Then I'm going to collect the dy dx terms, and I'll explain what that means on one side, and then solve for dy dx. Alright? So to find the derivative, the first step, differentiate both sides with respect to x. And just like before, I find my derivative of this side, which is x squared plus y squared. And I find the derivative of the other side of the equal sign, which is just going to be 25. Now, the derivative is still found the same way. I'm going to use the power rule, because it's x to the second, so the derivative is going to be 2x plus the derivative of y squared is still going to be the power rule. It's going to be 2y. But because this is a variable y, and this is with respect to x, there's a variable mismatch. So I have to multiply this by dy dx. So anytime there's a variable mismatch, aside from doing whatever rule you need to for the derivative, you have to multiply it by dy dx. And in class I'll further elaborate as to why this is true. Over here, the derivative of this constant 25 is going to be 0. Okay. And now I'm on to step 2. Collect the dy dx terms on one side. This doesn't have a dy dx, so I'm going to have to subtract this over to the other side of the equal sign. So this goes over there. So I'm left with 2y dy dx equals negative 2x. And then the last step is to solve for dy dx. So basically I have to divide both sides by 2y. And then I can reduce this. So this becomes dy dx is equal to, this becomes this negative x over y. So that was the first part, and then I wanted to evaluate this at the point 3 and 4. And notice my derivative has x and y in it, so I have to plug in both the x and the y coordinates. So now dy dx evaluated at 3, 4 is going to be negative 3 over 4. And that would give you the tangent slope at the point 3 and 4 to be negative 3 over 4. And in class I'll go over what this looks like and graphically what this slope represents on this curve. Alright, going over now example 2. Again, step number 1 is I want to find the derivative with respect to x of both sides. So it's going to be the derivative of x to the third plus y to the third minus 9 x squared y squared, and the derivative over here on this side of 0 is going to remain 0, but I'll get to that when I get to it. So going here slowly, the first derivative is just x to the third. It's just going to be 3x squared. There's no mismatch as far as the variables, so I don't have to worry about multiplying it by anything. Now the derivative of y to the third is going to be with the power rule 3y squared. There is a variable mismatch, so I have to multiply it by dy dx, and then minus 9. Now when I'm multiplying the derivative of x squared and y squared, this is going to require the product rule. So I'm multiplying this times this. So the product rule says keep x squared the same. So it's going to be x squared. This requires the derivative with respect to x. This is going to be 2y dy dx and it's going to be a plus. Keep y squared the same, and now the derivative of x is going to be 2x, and this is going to be equal to 0. So if you kind of think of this as the f and then the g, this is the f, this is the g prime, this is the g, and this is the f prime in the product rule. And then I can go ahead and simplify this. This becomes, this stays as 3x squared. This is going to be a 3y squared dy dx. I can go ahead and distribute this negative 9 into the parentheses. So I'm multiplying negative 9 and 2 to give me negative 18 x squared y dy dx. Distribute this negative 9 to this term, gives me negative 18 x y squared is equal to 0. And next step is to collect all the dy dx terms on one side. This doesn't have a dy dx term, this doesn't have a dy dx term. So what's going to happen is it's just going to be moved over to the other side, and so it's going to be 3y squared dy dx minus 18 x squared y dy dx equal to. This was positive on this side, so when I move it over it's going to become negative 3x squared. This term was negative, so when I move it over it's going to turn out to be positive 18x y squared. These two terms have dy dx in common. I can factor them out. And over here we're still on negative 3x squared plus 18x y squared. I can go ahead and divide now both sides by this that's factored out. And so that's basically the third step, is to solve for dy dx. So when I divide this over, I'm just going to put all this underneath it for my answer. It's going to be negative 3x squared plus 18x y squared. And then all of this is going to be divided over, so it goes underneath 3y squared minus 18x squared times y. And that is my derivative. Alright, last example. Find the derivative to this. So setting this up, it's going to be the derivative with respect to x. 2xy plus y squared, and the derivative on this side is going to be x plus y. Now, I have 2 times x times y. I can do the product rule on this. I consider this to be a f, and this to be a g. So it's going to be 2. Product rule says keep x the same. The derivative of y is 1 times the derivative is a mismatch, so it's going to be a dy dx plus keep y the same, and now multiply that by the derivative of x, which is equal to 1. So all this is the derivative of f. This is g prime plus g, this is f prime, plus, now the derivative of y squared is going to be a 2y. The variable mismatch, so dy dx. And then now the derivative of this side is going to be a 1 plus 1 dy dx. And over here, I can make a little note. The derivative of y, if I have a derivative of y to the first power, it's just going to be 1, dropping the power, subtracting it. And because of the mismatch, it's going to be a dy dx. And so this is just basically 1 times dy dx. So that's why I got my derivative of y to just be dy dx right here, and the derivative of y to be 1 times dy dx. Alright. So now, simplifying this a bit, I can go ahead and multiply the 2. So I get 2x dy dx plus, I distribute the 2 to here. I get 2y plus 2y dy dx equal to 1 plus dy dx. So step number 2 said to collect all the dy dx terms on one side. So I'm going to kind of have to move some stuff around. I have 3 terms that have dy dx. So I'm going to move this one over. So it's going to be 2x dy dx plus 2y dy dx minus dy dx. Because if it's positive on this side, when I move it over, it's going to be a negative. I had the 1. This term gets subtracted over on this side. And now all 3 of these terms have dy dx, so I can factor it out of here. So it's going to be 2x plus 2y minus 1 equal to 1 minus 2y. And then divide everything by this underneath it. So dy dx is equal to 1 minus 2y. All being divided by 2x plus 2y minus 1. That's your derivative. Now we'll take all of your questions on Monday.